Here we have AP calculus AB problem. Okay, let's go with the information. Let h of x equals to logarithm of x. Note, here we are referring to log to the base 10 and we have to find h double prime of x. Okay, here we have a logarithmic function that is h of x equal to logarithm of x and the base of the logarithm is 10 and we have to find the second order derivative of this function h of x. Actually, the given function is a logarithmic function and whenever I want to find derivative of a logarithmic function, the logarithm has to be a natural logarithm. That is, the logarithm must have base e. Usually we write the natural logarithm with the spelling ln. So if I write ln x, it's natural logarithm of x and the base of this logarithm is e. When I find the derivative of this natural logarithm of x, it is equal to, so I have to take 1 in numerator and in denominator I have to take the argument of the logarithm. In this case the argument is x. So 1 over x, that is the derivative of natural logarithm of x is 1 over x. So if I want to find the derivative of the given logarithmic function, so I have to convert this given logarithm to base 10 to natural logarithm. Okay, first let me write the given function as it is. That is h of x equals to log x to the base 10 because the question says the base of the logarithm is 10. So to get derivative of the given function, I have to convert this logarithm to natural logarithm. That is the natural logarithm is a logarithm with base e. So how do we have to convert this logarithm to the base 10 to natural logarithm? There is a formula for that one. Okay, now let me consider log a to the base b. Okay, in this logarithm, the argument is a and the base is b. If I want to convert this logarithm to natural logarithm, what I have to do is I have to write two natural logarithms in a fraction. For the natural logarithm in numerator, this a should be taken as argument. And for the natural logarithm in denominator, I have to take this b as argument. So this is the formula to convert any logarithm to natural logarithm. So the same thing I have to do over here in this log x to the base 10. So let me write h of x equals to, so I have to write two natural logarithms in a fraction. For the natural logarithm in numerator, I have to consider this x as argument. And for the natural logarithm in denominator, I have to consider this base 10 as argument. Then I'm getting ln 10. Okay, h of x equals to, here we can write this denominator ln 10 as 1 over ln 10 times ln x. Okay, now I'm going to find the first order derivative for the function h of x, that is h prime of x. Okay, here we have a product of two terms. One is constant and the other one is variable. I am saying this is constant because when I consider the denominator, it's ln 10 and this 10 is constant. We already know that. So whenever the argument of a logarithm is a constant, then the complete logarithm has to be considered as a constant. So this ln 10 is a constant. So when I divide the 1 by a constant, so the complete fraction 1 over ln 10 is a constant. So here a constant is multiplied by the variable. I say this is variable because this ln x contains a variable x. So when I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is. That I have to keep the constant 1 over ln 10 as it is, and I have to find the derivative of the variable alone. So when I find the derivative of this ln x, it's just 1 over x. Already we have seen the stuff over here. Okay, now I got the first order derivative of the given function h of x. Okay, so before I find the second order derivative, I have to need some changes over here. So let me write h prime of x as it is on the left side. 1 over ln 10. So this 1 over x can be written as x to the negative first power. Because the exponent of x over here in denominator is just 1. Whenever I move a term from numerator to denominator or denominator to numerator, I have to change the sign of the exponent. So when I move this x to the first part to the numerator, so I have to change the sign of the exponent 1. So already we have positive 1. When it is moved to the numerator, it will become negative 1. So when x to the first part is moved to the numerator, it will become x to the negative first part and it is multiplied by 1. So this is how we get x to the negative first part over here. Okay, now let's find the second order derivative of the given function. So already we have h prime of x. Now let me find h double prime of x equals to, again, so here we have a constant multiplied by the variable. Since we find derivative, we have to keep the constant as it is 1 over ln 10. So when I find derivative of this x to the negative first power, so I can use the power of derivative. That is, I have to bring this exponent in front of the variable and subtract 1 from the exponent. When I do so, I'm getting negative 1 times x to the power of negative 1. So again negative 1. So I just got this exponent negative 1 in front of the variable and subtracted 1 from the exponent. Now h double prime of x equals to 1 over ln 10 times negative 1 times x to the power of negative 1 and negative 1 will become negative 2. Okay, h double prime of x equals to, when I multiply this 1 and -1, it will become -1, or it can be written as -1 over ln 10. And here for this x, we have negative exponent. So to make this negative exponent as positive, I have to move this term x to the negative second power to denominator. When I move it to the denominator, the exponent will change its sign, that is, it will become positive 2. So then I'm getting 1 over x to the second power. So finally, h double prime of x equals to negative 1 times 1 is 1, and ln 10 times x square can be written as x square times ln 10. I got the second order derivative of the given function h of x, that is h double prime of x, that equals to negative 1 over x square times ln 10. We find this stuff in option A. The correct answer choice for this question is option A.